Matter is everywhere. Look around you right now, my friends. What do you see? So many things, I bet. Your chemistry textbook, the chair you are on, even the air you are breathing this very moment. All of this amazing stuff is matter. Scientists say matter is anything that has mass. And it must take up space, which is called volume. Think about a heavy school bag that has mass. And it definitely takes up space on your back, right? That's matter for you, plain and simple. The water you drink to quench your thirst? Absolutely matter. It fills up your water bottle and has mass. Why does an ice cube melt on a warm day? Why does a colorful hot air balloon float up high? It all comes down to the nature of matter. This knowledge makes you a super thinker. Matter is super versatile, you know. It doesn't just show up in one form. It can be a sturdy solid, a flowing liquid, or it can be a widespread gas. These are the three main states of matter. Think about water, our amazing H2O. It can be solid ice, liquid water, or gas like steam. First up, let's talk about solids. They hold it together. Solids are firm and they are strong. They have a definite shape and a definite volume. Your study table is a solid object. A shiny diamond is also a solid. Next we have liquids. They just go with the flow. Liquids are different. They can flow and pour. They take the shape of whatever container they are in, but they do have a definite volume, remember that. And then there are gases spreading out all over. Gases are all about freedom and wide open spaces. They have no definite shape at all. Think about the lovely smell of biryani cooking. That delicious aroma spreads through the whole house. That's a gas spreading out. So, we know matter can be a solid, liquid, or gas. But here's a super question. Can it change states? You bet it can. It happens all the time. This awesome transformation is called the interconversion of states. Think about an ice lolly on a hot summer day. It melts from solid to liquid, right? That's a change. These changes are usually because of temperature or pressure. Let's see how these fantastic makeovers happen, folks. When a solid changes into a liquid, we call it melting. This happens when you heat up a solid substance. The tiny particles inside get more and more energy. They start to vibrate much faster and faster. Soon, they break free from their fixed spots. Ice melting into water is a perfect example for you. The opposite of melting is freezing, you see. When a liquid turns into a solid, that's freezing. Now what about liquids turning into gases? It's exciting. When a liquid changes into a gas very quickly, it's boiling. This is also known as vaporization, a cool science term. It happens when you heat a liquid to its boiling point. Water boiling in a kettle to make steam is a classic. We've explored solids, liquids, and gases, which is great. These are the states of matter we see every single day. But hold on, are there any more states? Yes, science says there are. Absolutely. Scientists have found other, more extreme states of matter. These states exist under very, very special conditions, like super-duper high temperatures or incredibly low ones. Let's take a quick peek at two of these. Plasma, and the super chilly Bose-Einstein condensate, or BEC. Plasma is often called the fourth state of matter. It's a super hot, super energized kind of gas. In a normal gas, atoms are neutral, balanced, but in plasma it's so hot electrons get stripped away. This creates a hot soup of ions and electrons. Plasma is actually the most common state in the universe. Our sun and all the stars are giant balls of plasma. Lightning bolts during a thunderstorm? That's plasma too. Section 5. Sorting matter, mixtures, and pure substances. Okay team, we know what matter is and its states. But how do we sort all the different kinds of matter? Think about your kitchen again. You have salt, sugar, you have water, milk, maybe some tasty nimbu pani. Are they all the same type of matter? Not quite. Scientists classify matter into two main groups. These are pure substances and mixtures. This classification helps us understand their properties better. First, let's talk about pure substances. What are they? A pure substance is made up of only one kind of particle. It has a fixed composition, always the same. And it has definite properties that don't change. For example, pure water, H2O, is a pure substance. Every tiny bit of it is just H2O molecules. Pure gold, Au, is a pure substance made of gold atoms. Sugar, the sweet stuff, is also a pure substance. Section 6. The building blocks, elements, and compounds. We said pure substances are made of one kind of particle. But what are these fundamental particles really? Pure substances can be further sorted into two types. These are elements and compounds. Get ready for this. These are the basic building blocks of all matter. Understanding elements and compounds is super key in chemistry. It's like knowing the different colors of paint. You can use them to create any picture you imagine. So let's get to know these amazing building materials. First up, we have elements. The simplest form, an element is a pure substance. Listen closely now. It cannot be broken down into anything simpler, not by any ordinary chemical means at least. It's made up of only one kind of atom. Think of elements as the letters of the matter alphabet. There are about 118 known elements so far, like oxygen, O, hydrogen, H, carbon, C, and iron, Fe. Each element has its own unique special properties. Section 7, Matter Map, a flowchart to guide you. Phew, we have covered a lot about matter, haven't we? From its different states to how it's all classified, sometimes it really helps to see all this information, all organized in one single picture, a visual guide. A flowchart can be a super helpful tool for this. It shows how different ideas and concepts are connected. It's like a map for navigating the world of matter. So let's imagine a simple flowchart right now. It will summarize the classification of matter for us. Our amazing matter map, our flowchart, starts at the top, with the big word matter written boldly. Remember, matter is anything with mass and volume. From matter, it branches out in a couple of ways. Section 8. Why matter matters. Real-world wonders and your next steps. So, why is all this discussion about matter so important? Why should you, a budding scientist, care so much? Well, understanding matter is not just for chemistry class. It's fundamental to understanding almost everything around us, from the yummy food we eat every day, to the life-saving medicines that doctors prescribe, from the comfortable clothes we wear on our backs, to the amazing technology that powers our world. Every single thing involves matter and its properties. Think about all the applications, it's mind-blowing. Engineers need to understand the properties of materials. Materials are all different forms of matter, you see. To build strong bridges, super-fast cars, and tall skyscrapers, doctors and pharmacists need to understand substances, how different types of matter interact with our bodies. This helps them develop safe and effective medicines. Even chefs use their knowledge of how ingredients change. Ingredients are matter and heat changes them for cooking. What you have learned about matter's nature and classification.